All right, so we all plotted our danger bearing. All right, so if we're using Miller Lite, which is right here, as the object we're using to create our danger bearing, and we want to come unsafe inside here, then we can draw a line from here right along there, like that. Okay? And did anybody do that?
Yeah.
Okay, so what is this bearing magnetic?
I got 238.
I got 229.
271.
229 to 231, huh? Okay.
No, I got
Magnetic, all right?
True.
So, oh, that's true?
That's true. That's true.
All right, so what is it magnetic then? 8 more, right?
I use 229 magnetic.
Mine's magnetic.
I label magnetic, right? So what do I label it? 239, you said?
238. Yeah.
All right,
Somewhere in there.
238, 240, in that range,
Yep.
right? Magnetic,
Yep.
Not more
okay?
than.
And not more than, okay? Because if we're coming in at 270, we're gonna cross right over the shoal. So we don't wanna go more than 238, 240. Does that make sense?
Yep.
Okay, so it would be not more than. All right? All right, so that's your danger bearing. There's your line, right? 240 magnetic. Okay? And that's your safe area. Hard to read, but that's okay. All right, so the last, I think this is the last thing in this section, is current parallel to course. So, where's my, here it is. All right, so when it comes to current and trying to figure out how it's affecting your speed, all right, we're not going to get into, in this course, we don't get into current at an angle, okay, to your course. But we just think about it in simple terms. If it's parallel to your course, if you're heading this way and the drift is the speed, okay, and the set is the direction of the current. That's how they refer to current, set and drift. So a set of 270 means it's heading this way. A drift means it's at 2 knots, okay? That's the current. So if I'm in a boat and I'm headed just opposite, right at it, at a course of 090, right? And a speed of 6 knots, right? My speed over ground, okay? In other words, the actual progress I'm making, right? A knot meter on my boat is going to read 6 knots, but I'm not going 6 knots, right? I'm actually making progress, speed over ground, of only 4 knots, because the current's going against me. So you'll hear the term speed over ground, and that's your actual progress as opposed to what the knot meter on your boat's reading. Okay? Now, if we were to turn around and go 270, all right, then our speed over ground would be 6 plus 2, or 8 knots.
Now we're cooking.
Now we're cooking, yeah. As I say, now we're cooking with gas.
And this coastal navigation course is gonna be on rivers, that's why we're lakes and that's why we're only studying this, is because we might go upstream or downstream. We're
Yeah,
not
you
gonna
go up and
across
down the river, there's very little current in, Lake St. Clair that I've noticed. There's maybe some, but it's minor, okay? But yeah, if you go up the St. Clair River, okay, obviously, you've got current.
Under the Blue Water Bridge.
Oh, going under the Blue Water Bridge, Manitou just barely makes it, okay? Because the current coming out of Lake Huron into the river is so fast that going against it, trying to get into Lake Huron is a challenge for our boats. Okay? So that's just, that's all we're really gonna say about this subject. It's just the basic here that, you know, if your drift is against your boat, it's gonna cut your speed, and if it's with your boat, it's gonna increase your speed. And your knot meter's not gonna read the same. You can read your speed over ground on your chart plotter, okay, because it's doing it from GPS. So chart plotters will give you a pretty good an actual your speed over ground. But your knot meter in Lake St. Clair, it's going to be pretty close. But if you're in a river, it's not going to be close. It's going to be off. All right. Just a quick review, right? We know what an LOP is, right? It's plotted through a point. A line of position should be plotted true, labeled magnetic. Time at the top, direction below the line. All right. Bearings, if you take it from the boat's compass, you have to take into account deviation. If you use a hand bearing compass, you don't. Where two lines of position cross, you have a fix. All right. Closer the angle is to 90 degrees, the better. And a range is a line of position based on two fixed objects that are in line. Okay? And they're more accurate than a single line of position. All right? So, any questions on that before we move on to another topic? Trudy?
We are purposely using hand-bearing compass so we don't have to deal with the deviation. But it isn't always going to be without a deviation. It really depends on where you stand on the boat. You need to keep that in mind. We're just using it so you get through problems a little easier. Don't have to do deviation all the time. But you need to consider that if you are using the hand-bearing compass, you need to think about where you're standing.
So we don't have deviation charts for that.
Well,
Just stay away from the middle as much as you can.
Well, or boom box next to it.
Yeah.
Well, you know, you don't wanna be needing compass, it's like standing next to it. What's the thing with the hand-bearing compass? Where are you and what's near you? But when we're using it in this class, we're doing it so we're assuming you're standing somewhere that's okay.
All right, David. David's gonna discuss the next topic.
This is gonna be even more fun than a 3-bearing fix, let me tell you. In the last couple of weeks, you've been introduced, or in the case of some of you that have experience beyond what you've done in the club at L1, reintroduced to navigational aids and what they mean, how they're labeled, what some of the symbology is. Tonight we're going to dig a little deeper into that, those navigational aids. We're primarily going to look at lateral buoys and beacons that mark channels, channel intersections, entrances and exits from other bodies of water. We're also going to look at things like safe water marks and danger marks, primary and secondary lights. And we're going to look at each one of these things in 3 ways. We're going to look, first of all, what do these things look like from our vessel? When we look at them with our eyes, how do they appear on the water? Secondly, what they look like on a chart? How are they labeled? What are the symbols that are used? What do some of these sub-little symbols mean? And most importantly, what these nav aids, what the purpose of these nav aids are, what they mean, how they're located, why they're located where they are, and how they help us all navigate safely without running into stuff or each other, right? Does that sound worthwhile? That sounds worthwhile to me too. So, first thing I'm going to say is that there is the convention that we use, the standard, the system that we use is called the IALB Region B system, which stands for International Association of Lighthouse Authorities, and in IALAB, what that means is there's a certain convention in terms of when we're determining to see what colors on the right, what colors on the left. There is also an IALAA, which is the opposite of that, and there are a few other systems that are used in certain locations around the world. But our system, and pretty much anywhere in the U.S., the Western Hemisphere, especially around the Great Lakes, is always going to be IALAB. And what that means, and what you hear about this several times tonight, is that if you're coming in from a larger body of water into a smaller body of water, if you're coming in from the sea into a river, if you're going up a river, or if you're coming into a channel or a river from a lake, you're returning. And when you're returning, that means the marks that on the right of your boat, or the starboard side of your boat, are going to be red. The other ones are going to be green. And we'll talk about that a lot tonight as we go. So IALAB is red right returning. We're going to talk about buoys and beacons. Buoys are floating objects that are attached to the sea bottom. They're not always in the exact location, as Paul said earlier, because they can move around with waves and winds. One of the reasons we don't always choose them to take a bearing to get a fix. Beacons, on the other hand, are permanently fixed objects. They're fixed either to the sea bottom on a post or a piling, or they may be fixed on land, on a point of land or on the shore, like a range marker, for example. So, and then lighted beacons are called lights, obviously. Unlighted beacons are called day beacons or day marks. So we have buoys, beacons, we have lights, and day beacons or day marks. Okay, those are all terminology that you should become familiar with as we look at what things look like and how things are shown on charts. Most common nav aid that we'll probably use at L2 level on the Great Lakes and around these marinas are lateral buoys. Lateral buoys mark the channels that are coming either in or out of a river or a harbor or a marina, or marking the channel, like in this case, this is an excerpt from, you can see it's the shipping channel or the freighter channel right in the middle of the lake. And so we have lateral marks that are going up from, in this case, we're in the south, we're down the Detroit River, up towards the St. Clair River. So this is red right returning. So in this, we have the red marks would be on the right, the green marks would be on the left. In this case, these illustrations are of a green and red lighted buoys. So greens they'll always be the color on the left as you're returning. Red will be the color on the right as you're returning. So you see here, this is coming in. We're coming in from open water or larger water. Red's on the right, going into open water or going downriver or toward the sea. Red is on the left. Red, right, returning. Just if this is the St. Clair light right here, which is pretty much in the middle of your Lake St. Clair charts, and you notice that it's depicted differently than the buoy, and we'll talk about that. But even though this color is magenta, it's actually a green light because it marks this side of the channel for the freighters going up. And we'll talk about that some more.
So if you're going up the channel from Detroit to Falcon Lake,
Yeah, St. Clair River.
you're red. The buoy's going to flip halfway, or how does that?
No, they're not going to flip halfway because
aren't you going from a larger body into the Detroit River or into the Huron?
the larger body of water in this case is the Atlantic Ocean, right? We're
Okay.
going up the Great
So it's
Lakes, we're
always
going
the
through Lake Erie, we're going from Lake Erie to the Detroit River. That's up. We're still returning all the way up the Detroit River, all the way south to north up the lake, all the way through the St. Clair River up to Lake Huron. All that way we are returning from the sea, so you'll see red right returning the whole way. So these lateral marks can be more than just buoys, though. We looked at buoys on the last slide, right? So this green buoy is, we know it's lighted because it has a little magenta circle around the base of the rhombus. And the color of the rhombus is all green, so we know that it's green. And we know that it's, and then there's other stuff about lighting details, which we'll talk about in a minute. But it could also be an unlighted buoy. In the case of a green, we call it a can. Just think of a can of 7-Up, right? It's got an odd number, it's green in color, or at least they used to be, right? And it's shaped like a can. The red unlighted buoy is referred to as a nun buoy because it's kind of got sloped shoulders. It's supposed to be like a nun's habit, but it's just on a diagonal. They're always red, and it's magenta. The color of the rhombus is magenta, and you notice that the dot at the base of the magenta is an open white circle, not a magenta glowing little halo. That's how we know on the chart that this can, in this case, this green can C3, green can number 3, we know it's unlit, as on the chart, we don't see this, right? On the chart, we see this, we know that it's an unlighted can. We also can have, like in the case of the St. Clair Light, when the ferry's going upriver, they're going to have a lighted buoy on one side, which was depicted this way, and the St. Clair Light on the other side, which is depicted this way. And when it's a black dot like that, it's a beacon that goes right down to the floor of the lake in this case. So it's a very large light. It's on a foundation in a pier that goes all the way down. So a light can also be a lateral, or a light can be not a lateral aid. It can be another kind of an aid. And then on the shore or near the shore, we have these day marks and day beacons that in the case of green, we have a green 7 day beacon. Here we have a red 8 day beacon. And on the chart, day beacons, they're unlit, and they're also always indicated by a square or a triangle oriented straight upwards. They're never on an angle. The day beacons always go straight up. You see on the magenta teardrop on lights off to the side, lighted beacons or lighted buoys and unlighted buoys are also tilted to the side. Day marks and day beacons always straight up, 90 degrees. And again, you can see here, this would be red right returning. Red would be on the right. If we're going down, heading out, in this case it'd be south on Lake St. Clair, or heading south out of a channel or a marina going out to larger water. Then our lateral aids would be green on the right if we're going from smaller body of water to a larger body of water, or downriver or out to sea. So as I said, there's lighted lateral buoys. They're identified by a number of characteristics. They're going to be color, a number. If they are lighted, they're going to have to show light characteristics. We'll talk about that convention a little bit in detail. The actual shape, like we said, isn't significant. If it's a lighted lateral buoy, it could be a buoy, it could be a light itself, it could be something else. So the shape is not really the most important thing. But the red buoys always have red lights, and you guessed it, the green buoys always have green lights. Let's take a look again at lighted buoys. So we'll take a look at both the depiction here, and once again at the labeling and what it says on the chart. So we have here a green buoy, number 13. It has a light on it, and so on the chart we see that it's totally green. It's green because the whole rhombus is green. We know it's lit because there's this magenta halo around the base of the symbol. We know it's number 13 because on the chart, 13 is in quotation marks. So it's green buoy number 13, and then the line below that tells us some characteristics about how this light operates. In the case of this, we see FLG 4 seconds, which means what? Anybody?
Flashing green.
Flashing light, flashing green light at 4-second intervals. So green number 13, sorry, and light is flashing green every 4 seconds. What about this one? R24. It's hard to read. This is FL, it looks like a little A, but this says F little L, so that's also says, so it's flashing red, right? At an interval of 2.5 seconds. So the top line on the chart tells you what this buoy, this mark is, and because it's lit, the second line tells us the characteristics of that light and what we would look for at night. Not going to be doing it during the day. It's going to be doing it after. It's not going to be doing it quite at dusk. It's going to be doing it at sunset. It'll start to blink.
Is there any significance to the interval, 4 seconds versus 2.5 seconds?
Not particularly. There are some standard intervals, like for example, it's almost always, if you have a safe watermark, it almost always blinks a certain color at 2+1 at 6 second intervals. And there's some things but they're set. But the rule of thumb is look at the chart, understand the characteristics, read it off the chart. There probably are some very similar ones, but.
Is that so that you can just identify it without knowing necessarily, oh, I'm at 13, I can recognize it from the chart?
Yeah, you know what,
By the
saying,
flashing?
I know I'm looking for number 13.
Okay,
It's probably a mile away, so I'm not gonna be able to read that number off of it,
right,
because it's
exactly,
too far
so
away.
you can identify
But
by
at least I know which
Okay.
one I'm looking for, I know its location, and then if it happens to be at night, you can find it a little easier by its light sequence, by its
Okay,
timings.
okay.
Day beacons and day marks, again identified by shape, color, and number. They're fixed to either the bottom of the water body at very shallow water. These are often in shallow water, or they're actually on the shore, again straight up. So we have a green unlighted day mark, which will look like this if you're looking at it, and it'll say G5 on the chart with a square going straight up. Similarly, for red day mark number 2, it's we're gonna see it as a number 2 with a red inside of a triangle, and on the chart it'll be a red triangle facing upwards. So green day mark number 5, red day mark number 2. Any questions? Okay, a little bit more about unlighted lateral buoys. I mean, we talked about this a little while ago, so I'm just going to go real quick. But again, shape, color, and number. The unlighted buoys are to our starboard. As we turn the ones to the right will be the nun buoys, which are red in color. Okay, these are the nun buoys, and they always have even numbers. I used to play with my kids as we were driving, up out of Lake Erie up towards Gibraltar and Roselle, and we've been out fishing, and I would say, what do you think the next next red buoy number is going to be? And I just passed number 4, and I'm heading in, so I knew the next one's going to be 6, right? But I'd say, well, they say, I don't know, Dad, I think it's going to be like 13 or something. I said, I bet it's number 6, and so a good old number 6, here it is. But as you go up from the sea, the numbers on these lateral hazards will increase. As you go down, the numbers will decrease. So if you're heading up, let's just say that we're heading from Detroit up the shipping channel. Well, it wouldn't be the shipping channel because these are unlighted. But let's say we were heading up another channel from the sea where we had unlighted aids. They would start with 1 and 2, then 3 and 4, then 5 and 6, and so forth. That's the numbering sequence. So again, what we've got here is red nun number 4, unlighted because there's an open white circle there, so it's unlighted. And we have green can number 3, again unlighted because there's an open white circle at the base of the rhombus. All right, we got that. Cardinal buoys. Cardinal buoys indicate a danger relative to the buoy itself. So if we look at a cardinal buoy, we're saying, let's say the danger is right here in this little yellow triangle. A cardinal buoy with 2 triangles facing north means that you want to pass north of the danger. 2 triangles, and these are always black and yellow. The location of the black and yellow stripes depends on which cardinal buoy it is. In the case of south, we have 2 triangles going down. That means you want to always pass south of the danger. Same with west, we have 2 triangles kind of pointing at each other. and the east cardinal are two triangles facing away from each other. You're not going to see these very much in the Great Lakes. There are a couple of them in Georgian Bay, but you're not going to see any of these on Lake St. Clair. But they are something that you might wind up getting tested on. So you might want to file that away. The thing about, so this picture right here is which of the four cardinal buoys would this one be?
So,
It's a south cardinal buoy, so this means you want to go south of that buoy. We don't have to know, we don't have to have a lateral buoy. The thing about cardinal buoys, it tells the danger relative to a direction on the compass, not relative to another lateral buoy. So that means as long as we're south, and we could be, as long as we're south of that buoy, we're out of danger. So don't think of this as being, this is this, and so they're sailing through the danger. We're probably looking south from north, and so he's south of the danger. I'm standing on the danger. Here's the danger mark. This nice little gaff-rigged sloop is sailing south of the danger. So it doesn't really matter which direction you're going, whether you're going 090, 270, or whatever. It always tells you you want to be south, in this case, of the danger. So that's the beauty of the cardinal marks. You don't have to have a second point of reference. And you often see these kind of marks at entrances to harbors, around a point of land that might have a rock or a wreck. It just usually tries to keep you out of a very subtle area of shallow water or hazard. Another type of danger mark is called an isolated danger mark, and these are always black and red, and they have two black spheres on top. And what these danger marks indicate is that there is a danger right at the location of that buoy, and that there is safe water generally all around it. I mean, I wouldn't say come within a boat length of it, but I'm saying if you're 2 boat lengths out from it, you can sail on all, you can come around any of these, and you're going to be out of danger. They might be lettered, they might not be lettered. In the case of this one on the left, BR isolated danger mark A, you know this one's lit, right? Because we've got the magenta circle and we've got some light characteristics. What are those light characteristics?
two flashes.
Flashing light 2 every 5 seconds. And we have this one, BRC, and what kind of light does that have? It's got no light. You see, there's no light on top of it. There's no light. It's an open circle.
And the BRC are black red.
Yeah, that's black red. Yeah. So, the last specific mark I want to talk about in terms of junctions and channels is a junction buoy called a preferred channel mark. And what that does is it's put mid-channel. It marks the fairway or a split in a channel or an intersection, and tells us which way is the most preferred channel, the safest channel. It doesn't mean the other way is unsafe. It just means that one way or the other is the preferred channel, the more direct route, especially for larger vessels. But it doesn't mean you can't take the other direction. It just means that one direction is the preferred direction. And usually these occur adjacent to rocks or shoals or a point of land or something that dictates the channel is going to have an intersection. So in the case of this example right here, which is at the very top of Lake St. Clair, going into the St. Clair River, we actually have a green and red preferred channel marker right there, and that tells us which way is preferred and which way is secondary. You can actually travel either way. This should look very familiar to you by now. What does that look like? We were just plotting a danger bearing off that a little while ago. That's the north buoy, isn't it?
Mm-hmm.
Look, what do you know? That north buoy is actually a preferred channel marker. And we'll talk about that too, but this is green over red, and this flashes, again, 2 + 1 green for a 6-second interval. So that's and we'll talk a little bit more about how that works. But we think of that as the north buoy. We think about that as a way to stay off the shoal, but actually, the north buoy is a preferred channel marker. So how do these work? Well, if it's green over red, is gonna look like this. It's gonna have, the rhombus is gonna have green on top, red on the bottom, and obviously it's gonna show that it's lit. So here we have, this is essentially what we just looked at. The north buoy is depicted like this, and it says I'm a junction buoy or preferred channel buoy. It's green above, red below, light flashes twice, flash, 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 5, 4, 3, 2, 1, flash, flash, flash. In this case, it's gonna be green, 6-second intervals. If we had one that was the opposite, we'd have red over green, and that would indicate that the preferred channel, that red is on top, and so the light flashes again, it's gonna flash red, 2 + 1 every 6 seconds. So how does this all break down? If the top color is green and you're returning from the sea, then your preferred channel is to your starboard or to your right. So which means that in this case, you'd be going this way. You'd be going right of the buoy, right? You would take the buoy off your port side. If the top color is red, and again, you're returning from the sea, going from a larger body of water, or you're going upriver or larger to smaller, then the preferred channel is to the left, or port. You'd be going over on this side, and you take this buoy off the starboard side of your vessel. Any questions? We're gonna do some practice, but Avery, you look.
No, I'm just
All right.
repeating what you said in my head.
Yeah.
But it's effectively the same as the other buoys, right?
Right, the top, if you think that, if you wanna follow the preferred channel, you're probably gonna just ignore the bottom half and assume that the top one is what controls. And we'll look at that right now, we'll practice that a little bit. But it's always best to check the chart, because you might actually wanna take the unpreferred channel. That's because it's the preferred channel, it probably means it's the deepest, widest, safest channel with the less obstructions. But it doesn't mean you might not want to go on the other way. It doesn't mean the other way is unsafe. It just means it's a little bit harder to navigate than, or maybe a little bit less direct, or maybe it has more bends to it. These are the things that actually make it not the preferred channel. So let's practice, okay? So what we have here is one that looks a lot like that example we looked at the very top of the lake when it's going into the St. Clair River. And what we have here is a preferred channel marker, green over red, and we won't worry about the light characteristics, the same light characteristics we already talked about. So we're returning from the sea, we're going south to north in this case, so we're coming from, let's say it's Lake St. Clair, and this is the St. Clair River. So we're coming in, we've got red right returning here, and so which direction is going to be our preferred channel, to the right or to the left? To the right. That is correct. Again, so we're red right returning, green over here. This would be a secondary channel, might be the way you want to go. Might be a marina down that channel you want to go to, but it's not the preferred channel. The preferred channel in this case is to the right. All right, let's turn it around. All right, let's say we're coming in, again, we're coming in from this direction. Now our preferred channel marker has got red over green instead of green over red. So now, where's our preferred channel? To the left, right? Because now we're red right returning. We're going up here. We have a light here that also is indicated that's red. You have green over here. So red right returning would, in the IALAB system, would take us up that way, right? Which is what the would say. Okay, making sense? Let's try the other direction. Now we're actually going out to the sea. We're gonna be going from this direction. We're coming down and we're going out to the sea. So our red is not going to be red right returning, or we're going to be left right returning, right? So here's our junction. We have green on top, red on the bottom. Which direction is going to be our preferred channel? In this case, we're going out to sea, not coming in from the sea. Left, right? Because again, going downbound, our red is going to be on our port side, not on our starboard side when we're going out to sea. And again, flip it around as we did before. We're going from the upper left, we're coming down out to sea. We got red over green now. So now our preferred channel is down this way. Questions on preferred channel? Okay.
No mnemonic for returning.
There's no,
Going
left
out.
not returning, I don't know, does anybody have one?
I've been trying
I
to
guess
come
the
up with
opposite of
one.
red right returning is what I,
Red left, green.
okay. So
Red right return, red left, green.
let's talk about lights a little bit. You know, again, lights or beacons with aids, they're fixed to the ground or the sea bottom or the lake or the river bottom. There are primary lights that are designated usually because of their size or their importance, like the St. Clair light, for example, is a primary light. There are secondary lights, which one of the secondary lights we looked at in our tube bearing fix problem was that secondary light along the shore just north along the lake shore north of JBM, right? That was a secondary light, but it was a light, not a buoy, right? So the St. Clair light, which you can find, you know, almost dead center right in the middle of your chart of the lake, is labeled this way. It's labeled Lake St. Clair light, ISO G6S, 52 feet, 6 STM. And actually, rather than having a magenta dot, it's actually got a black dot. Most lights, most beacons, the light is a teardrop, but it's a black dot rather than a magenta dot. So anyway, so if we look at this is saying I'm a light beacon. My name is a Lake St. Clair light. My light is isophase. What isophase means is that on and off at equal intervals. ISO means an equal on, equal off. 6 second, 52 feet. That means that's how high the light beacon is above the surface. And 6 statute miles, that's the distance you can see that light at night with good atmospheric conditions. This example was created a few years ago, and the light since been upgraded. I'm pretty sure if you look at your chart, it's going to say 12 statute miles rather than 6 statute miles. So just pretend that the slide says 12, okay? Because that's obviously the light was improved or upgraded since this came in. So what about this secondary light? Somebody take a shot at describing that light. How would you introduce yourself if you were that light?
Flashing red.
At 4-second intervals, it's 30 feet tall, and it's visible for 5 statute
Five statute miles.
under good
And
atmospheric
it has got
conditions.
a
and
name.
it's
It's
got a
number 14.
Yeah.
So it probably would be, you'd probably see it on a number of pilings or spars coming up attached to the sea bottom, and you would see a number 14 on it, and then the other characteristics. Doesn't really have a name except for 14. That's its name.
I had a dumb question on lights.
Yeah.
So are these on timers or are they on photosensitive? So like big thunderstorms where the sky gets dark, so they come on, or is it just?
I don't know. They could be controlled by computers. They could be controlled remotely. They could be have some kind of wireless technology. They at one time I'm sure they had mechanical timers. I'm guessing they have something better now, but that's a great question. I honestly don't know the answer to that. Anybody have any idea on how these lights are actually function mechanically?
Be helpful if they came out and thunderstorms falling.
Lights only come on at sundown, sunset to sunrise. Okay, we talked about range lights before, so I'm not gonna dwell on it. Again, like Paul said, a range light means that there's a light that's nearer to you, or nearer to your fairway, nearer to your channel, that's gonna be lower than the other one. Sometimes these are range lights, and so they're lights on little towers. Sometimes they're range marks, which are just little day marks that look like this. Sometimes they're not even lit. But what I wanted the illustration I wanted to show you is that obviously when you got one over the other, when your ranges line up, you're right in the center of the fairway, you're right where you want to be, right? If you see it where your front marker or the lower marker is right of the top one, you know you're left of where you want to be. And if your front marker is left of the top one, you're to the right of where you want to be. You want to come to port. So again, we talked about ranges, and we'll talk about ranges more in some of the homework problems. But pretty basic stuff. But it does. There are a lot of different range markers on almost every little river that you'll see on your Lake St. Clair Sharp, whether it's Bell or whether it's the Thames, whether it's the Clinton, whether it's various places along the St. Clair River. You'll see these range lights, and they can come in very handy if you happen to be traveling at night or if you're in a very narrow channel. Last buoy we're going to talk about is safe watermarks. And safe watermarks, this is what they sound like. There's safe water all around. They're usually, almost always wherever I've seen them, they've always been at sort of the outer marker junction fairway, and they'll be before you get to the lateral buoys that mark the left and right side of the channel. You'll see a safe water buoy that's out in the middle that you sort of sail, you can navigate towards, and then go from there into the channel. They are always red and white. Sometimes they're lit, sometimes they're not. In the case of this one, we know it's lit because it has the magenta circle, and it also has a little thing on top. And this one is named RWCR, RW because red and white, and it says MOA, which actually in this case means Morse code letter A, which is dot dash, which is die dot, and it will do that at an interval of, gosh, it's just a couple seconds, but what you'll need, there'll be enough of a space to show you that it's sending the Morse code letter alpha. They have no lateral significance. In other words, there's safe water all around. I used to go right past them to make sure I was in the deepest water, heading in towards the marked channel. So as long as you don't, you can go as close as you want, as long as you don't hit them. So again, this is a safe water mark, or sometimes called a fairway buoy. It's designated CR, and its light sequence is Morse code alpha. Lots of different kinds of safe water marks. This is the one that we just looked at, is like this. Would be a safe water mark N. Here is N. What's the difference between these two?
One is lit.
One is lit and one is not. Right. But there's also there could be day marks. There could be a spherical ball. There could be a can. There's different, but if it's red and white, it's going to be a safe water mark or a fairway buoy.
Red and white, you'll be all right.
Red and white, you'll be all right. Now that's a pilot saying for VASI, right? It means the vertical. What's that? The vertical approach slope indicator, visual approach slope indicator. Yeah, red and white, you're all right. Red and red, you're dead. Yeah, right. Okay, a little pilot lore there. Here's a safe watermark fairway buoy on the Clinton River, which is, we looked at a little. It's the next river up from Metro Beach, along the west shore of the lake. Here's another one that's down on the Thames River, which is one of the buoys you want to navigate to for your homework assignment. And again, these are all fairway buoys. There's also range marks if you want to look at these two things. Here's a range mark going into. Is that Metro Beach or Clinton River? I think it's the Clinton River. That's the Clinton River. So you can actually see, if you look on your maps, you can see this is the upper range mark, this is the lower range mark. There's a little range line in there. It doesn't extend out there, but you can see there's a range mark. And here's the lower one is 26 feet high. The 26 and 25. The one behind has got to be higher than the other one. That's the way they work. So I don't know why this label looks a little funny to me, because this says that this one's 26 and this one's 25. And that's not the way they're supposed to work, so.
I mean, it might be higher on land.
Maybe that is the height above the base, but the back range light is always higher than the one that's closer to you.
That one would depend on whether you're going out as a river or going into the river.
Yeah, but in this case, you're going in, so this one should be higher. And there's a range down, there's another range down here for the Thames River, so. Some of these light characteristics we've seen, for example, we've seen FL, which means flashing, in this case flashing 2+1. We've seen Morse code alpha, that's a light characteristic. We've seen isophase, which is equal on and off. We've seen quick, which is like isophase but more quickly. There's also some odd ducks like very quick, which is very quick but sort of an isophase, but it's blinking very, very fast. And there's also occulting, which means that it goes on and off, but it's on longer than it's off, so that the light is on longer than it's dark. So it's long on, short off, longer on, short off. And those use OC. Those would say OC. So again, there's a reference saying, how am I ever going to remember all this stuff and all the stuff that David hasn't even talked about yet? Well, there's actually a book that you can refer to answer all these questions, and it's called U.S. Chart Number 1, and you can order it it's for a song. It'll give you details of all these symbols, all these conventions, whether it's NOAA conventions or the chart conventions. You can find all this stuff in U.S. Chart Number 1, and you can actually find it on the internet pretty easy too. So, anyway. Okay, let's review. What do we see here? What's this down here? So we're coming in from open water into a channel or a river. What's this down here? Safe water mark, or fairway buoy, right? What about these two? Lateral. Are they lit?
Yes.
Yep.
How do we know?
Because they've got an agenda
Okay.
on the bottom.
What's this?
Preferred channel.
A preferred channel marker. It's red over green. So where's our preferred channel? I know, it's the white.
Yeah.
Right? So we're red over green. So this is our preferred channel marker. What are these things? Ranges. Okay. And we got this one. In this case, it's a red on 6-second intervals, and this it's a quick red. So QR means quick red. This one's going on and off red every 6 seconds. This one's blinking red. Makes it easy to line up the range. You're right in the center of the channel. You're good to go, right? What about this thing over here? What's that?
Danger.
It's an isolated danger mark, right? 2 spheres, black over red. It means stay away. It's right over the danger, and so you want to stay 2 or 3 boat lengths away all the time. What about going over here? Can we go over here? It's a channel. There's these. What are these things called again? Day marks, day beacons. We can go over. There's a channel over there, but we have to make sure that we have enough navigable water depth. Maybe the reason might be that if you've got a little dinghy with an outboard, you can go over there. But if you've got a sailboat with 4.5 or even 5 feet of draft, maybe you're not going to want to go over there. If that's when you have to go back and check your navigable water depth. So we also have light over here, light over here, light over here. Couple of buoys over here, red and green, but these aren't lit, are they? How do we know? So, open white circle at the bottom, right?
What's the white square on the bottom?
Ah, great question. That's actually it's a informational mark. It's a type of a day mark, but it's not so much for navigation as for info. So this might say that there are stakes, or there could be some stakes in here. There could be some fishing here, there could be, but this is gonna give a piece of information. And these can be all different colors, by the way. They could be white, they could be white and red, they could be black. They usually pick the colors for these based on contrast with the land and the foliage around them. But but this is not, so it's really not technically a day mark or a day beacon, it's an information aid. Good question. So, speaking of navigable depth, how do we know that we can or we can't take the boat to the right in that last little example? Because it was not the preferred channel, but it was a channel. How do we know when we can go in there or not? Well, I'm glad you asked. So let's take a look at a problem. We've given a chart datum depth of 3 feet at a location. I'll show you in a minute. By the way, you can find this in your I think, on page 34 of your primer. The same problem we're going to work through, so you might just want to take notes on that page. So we have a chart data. So it says 3 feet on the chart. So 3 feet above datum is the surface of the water, low water datum. We have, based on our local notice to mariners, or we've checked with NOAA, we checked with an authority, Coast Guard, whoever, we find out that actually the depth today in Lake St. Clair is 42 inches above chart data. We also have waves that are 2 to 3 feet, and we're going to say that our boat draft that is all the way down to the end of our wind keel is 4.5 feet. So that's what we don't want to hit. And we're going to say, is it safe to sail at this particular location? So let's work the problem in steps. So first of all, we've got chart datum, which is 572.3. We're 3 feet above chart datum, right? So that would give us 3 feet of depth. And we say the water surface based on that alone would be here, 3 feet of water depth. We also know that we're 42 inches or 3.5 feet above that chart datum. So that would say that, so 3.5 feet, so now we're up to here, we're up to 6.5 feet, and that seems like plenty of water to get our boat with a 4.5 foot draft through. It would seem that way, but hang on, we've got waves of 2 to 3 feet. So we're going to take the larger of those two, we're going to say 3 feet, and we're going to say, if we have a 3 feet wave, we're going to have half of that is going to actually be below our 6.5 foot level. So now, rather than have 6.5 feet, we've only got 5 feet of actual navigable depth below our keel, or more importantly, below our wind keel, the lowest part of the boat, the deepest part of the boat. So we have, and what is our draft? 4.5 feet. And how much room do we have?
6 inches.
Yeah. Is that safe?
No.
I'm not sure I want to do that. No. I mean, technically, you could say you could make it, but 6 inches. What if there's a rock? What if somebody dropped their toolbox? What if a spar fell off someone's boat and it's lying, that's not enough, there's really not enough room to be safe, so.
So
What is a good safety margin?
Personally, I never go less than 2 feet, and I'd rather not even be that close. Trudy, do you have any thoughts about what's, safe depth? I mean, it might depend on conditions, how much waves, but I like to always have at least 2 feet, and that's only if I'm really close to shore. If I'm sailing out in the middle of the lake, I'm gonna plot a course around shallow spots, But if I have to go into a harbor, then that's what I'm gonna be looking at.
Yeah, I like a little extra room. I like to be cautious.
Yeah,
Don't get too close to danger.
yeah. So,
What's that
and the thing
price?
is that you never know what's on the bottom that isn't on a chart, because something could be there.
All right, so you're reading the chart datum depth off of this. Where did you get the NOAA depth above chart datum?
That's a great question.
I was just gonna say.
I mentioned
you got
local
your
notice to
phone?
mariners, but go ahead.
Do you have your phone,
I do.
smartphone? Can you Google? If you Google U.S. Just Google Army Corps of Engineers, Great Lakes water level update. Okay, And in fact, I think Trudy handed out, did you hand out one of those reports?
Yes, and it's shorter, all you have to do is.
I think you did.
I also, you can also go to Coast Guard District 9 local notice to mariners.
Looks like
and,
this.
and will also be on about page 7 or 8 of the local notice to mariners. So there's a couple places you can get this information.
Yeah, I just look on here and it's got it listed for the current week, right? Army Corps of Engineers, water level for Great Lakes. And for instance, it says right now, chart datum it's got, and
I've got
difference from
17.
chart datum, I've got plus 36 inches.
Plus 36 is what I got too, and that's from Coast Guard District 9. So I want to, but it's the same chart you're looking at.
So
I
it's
think.
3 feet.
Yeah, it's the
Yeah,
same one.
Yeah.
So is the chart datum number kind of like it never goes lower than
Correct.
the chart datum?
Remember-
That's the
Correct.
absolute minimum.
Remember your
That's what it's supposed
this is,
to be.
This is your
Yeah.
chart datum here,
Yeah, it's the lowest
572.3,
low.
right? It's on your chart. So when 3 feet is marked on your chart, it's the depth of water, based on the chart datum. So 3 feet is what's marked on your chart, but that's minimum. It doesn't mean that the important thing is that there's going to be less water or more water above what's marked on your chart, and you got to know when you go out that day, what are the conditions on Lake St. Clair? Am I plus 36? Am I plus 10? Am I plus 0?
Does it vary that much?
It
Day to day?
not day to day. No, it's been probably plus between 2 to 3 feet for the last 3-4 years. But
There was a few years ago where it was very low.
actually Lake Superior, which is the engine that drives the water levels in the Great Lakes, is only 9 inches above datum right now, and that's the lowest it's been for a few years. So I'm expected it's not going to stay at 36 for many years, but we're probably going to be up for most of this year.
You can just say Lake St. Clair water level and then pick the Army Corps of Engineers.
Yep.
You don't just get one lake, you get all the Great
Yeah,
Lakes
Right.
in
they're all
front,
in
so
there.
it's a
Yeah.
quick and easy way to get it.
Okay.
And you might be needing to use it tomorrow, or for your next lesson.
Book market.
You just might be able. You just might be. Well, that's
You
a
have a
good
question
question.
up there.
Yes.
Can we go back to the previous slide for a second? Where did you use the chart datum in your calculations?
I didn't use the chart datum so much as I knew that the 3 feet of water depth I started with was based on the chart datum. So that means based on the chart datum, the mean low water depth that's on the chart was 3 feet. So I looked at my chart where I was, it said 3 feet, and I knew that was based on the chart datum.
Okay, you know it's 3 feet, then you looked at NOAA, that was 3.5, so you're at 6.5, you know the wave height, so you took off 1.5 feet, so you were at 5 feet, and your boat is 4.5, so you didn't actually use the chart datum.
I didn't use the chart datum in the
Okay.
math, no, I just know that 3 foot contour on the chart, if you will, was based on the chart datum of 572.4.
What
So
is
I'm
that?
confused. I thought that chart data number 3 was what you're actually reading off the chart, the road or where you're going to be. Is that what I'm looking
That's
at?
exactly
the
right,
number
that's what
on
I'm
the chart.
reading. I'm looking at the chart, I'm looking at the contour, where I am. If I'm into this shallow water, if I'm coming, or I know approximate location, that means that's what the chart reads, the chart, but I know that I have more water or less water based on the actual depth above or below datum.
What is that 572.3 figure? Is that above sea level or what?
Yes.
That is the mean elevation above sea level, yes.
Of the lake surface.
So the datum, if you the datum or the benchmark that the datum is based on is actually sea level, which could be considered another datum. But 572 above sea level is what we, and that's what our mean low waters is based on. Okay? Pretty simple math, but the point here is remember that you're going to have more water or less water than what your chart says, and depending on your wave action, you may have even less than that. That's the point, right?
All right.
And if you've got 3 foot waves, you may have 4 foot waves.
Yeah. So listen, let's talk. This is we're almost done. but I want to talk about something called geographical range, which you can find actually on page 44 of your primer. The same problem will be there. Geographical range is simply how far can you see from the horizon to a certain height before you lose that visibility based on the curvature of the earth. That's what geographical range is. Geographical range can be calculated based on an equation, the square root of the height in feet, in either the height of a beacon or the height of someone standing off of a boat. Height in feet times 1.17 equals the geographical range. So in this case, in this example here on the screen, we're assuming that I'm treading water in the lake with my eyes right at water level, okay? How far can I see a beacon, assuming that atmospheric conditions are such and that the light is bright enough? How far can I see this beacon 65 feet off the surface of the earth before it disappears and the curvature is such that I'm not going to be able to see it? So we take the square root of 65 feet, so the square root of the height in feet times 1.17 equals a geographical range of 9.43 nautical miles. But actually, I'm not really going to be treading water in the middle of the lake with my eyes at the level of the lake. One would hope not, unless one of you leaves me behind and doesn't come and do an overboard, and we hope that will never happen. So let's look at another case where it's a little bit more realistic, which means that I'm actually going to be in a boat over here, and I'm going to be somewhere above the water. And in this case, I'm in a pretty big boat with a lot of freeboard because I'm standing in the boat, I'm standing in the bow, or I'm standing on top of the cabin, and I'm 15 feet above the water line. So I go and take the square root of 15 times 1.17, I get 4.53 nautical miles, and that's how far I can actually see from the boat before the horizon will lose anything that was actually, let's say, in this case, the light or the thing I'm looking at was floating in the water, right? I could see it for 4.53 nautical miles, again, assuming that atmospheric conditions, there's no fog, there's no, but assuming that I could see that far with my binoculars or whatever, 4.53 nautical miles. But let's say I'm not looking for something floating in the water. I'm looking for that other beacon that we were talking about before. I'm looking at something that's actually 65 feet off the surface of the earth, and it's around the curvature. So again, we're looking at, in this case, we're looking at the square root of 65 again, times 1.17 gives us our 9.3 nautical miles. And so if I'm standing on the boat, then what I'm going to be able to see is actually, rounded up, 14 nautical miles is my geographic range from standing on the cabin of the boat before I'm going to lose sight. Anything more than that, anything outside of 14 miles, that beacon, even though it's 65 feet high, is going to disappear below the horizon. Make sense?
Couldn't I just subtract 15 feet from the 65 feet and calculate for 50 feet if
No.
I'm 15 feet above water?
It won't work that way. You need to do it both. You need to do the calculation both ways because of the square root.
Oh, okay.
So let's do a quick problem, and then we'll be done. So again, we're on a different boat. Now I got the boat is. I have a freeboard of 3 feet, and I'm standing on the bow, so I've got 5 feet from the top of the freeboard to my eyes. So my water level, my eye level to water level is 8 feet, right? So how do I calculate the geographical range of this to the surface of the water? Right? 8, square root of 8, 1 times 1.17. Gives me a geographical range of 3.3 nautical miles. Again, that's the first part of the same example that we did before. We have a different light here. Our range from light is 52 feet, not 65 feet above the water. So square root of 52, 1.17, and so that component of the overall geographical range is 8.4 nautical miles. So again, the range from where you or I are standing in this boat, 8 feet above water level, to this beacon that's 52 feet above water level, is going to be the addition of those two things, which is 11.7, or 11 and a half, between 11 and a half and 12 nautical miles.
Good question. I mean, I understand all this, but where are we applying this?
Well,
How do we apply it?
the application is, if you're looking in a practical sense, I'll be honest with you, I've never actually done this calculation while I'm sailing, so I'm not gonna pretend that I've ever done it. But if you're at night, and if you're looking at a situation where you're steaming or you're sailing towards a beacon, and you want to know, when am I going to see that beacon? At what point, at what position, at what location will that actually become visible? And this is the absolute maximum where it would become visible. So there's no point in looking at it if you're still 14 nautical miles away. That's my practical answer to your question. Anybody else?
You've got the St. Clair light. How high is it? I think it's 65 feet, isn't it? I forgot. Look on your chart, it'll tell you how high. So how far, you might want to know, when can you see it? How far
It's
away?
52 feet, 12 nautical miles. 52 feet is high.
52 feet?
Yeah, so this could be.
That's a pretty good estimate. You gotta be within 12 miles of it to see it. And if you see it, you know you're within 12 miles. That's the minimum.
So it's, when does it appear? When do you expect it to appear? But if it's hazy, or or it's foggy, or something, then that rule might not apply.
It's gonna be even less.
Yeah.
If you're actually in the water and you have to swim to the land, it would be helpful to know, when you see the land, how far away you are.
I'm gonna come back and get you, brother. I'm gonna come back and get you. I promise I will.
You better have a calculator to figure this one.
So you have to calculate your freeboard.
You already know the answer.
So
When you're
you
in the
have to
water,
calculate your
you
freeboard,
see
and
the
you have to
land
calculate
on the horizon.
Estimate. So
It's a
you
3-mile swim.
The assumption is that if you're on a boat, say it's Windsong or say it's Manitou, you're going to know that you're between maybe 3.5 feet. If you're standing on the bow, you're going to be that far above the water surface. So it's freeboard plus the slope of the deck or whatever, and then you're going to stand up. Well, you're 5 feet or 5.5 feet. So you don't have to so much calculate it as that you'll know the boat you're driving. You'll know basically how far above the water you are, and if you're not sure, then you can just estimate.
Right, so view from water level plus view from on the freeboard.
Right.
Okay.
Yeah. So it's the height of the beacon and the height of the beacon looker. Avery.
So what is the diameter of the Earth that this is based on? I mean, I'm trying to figure out where this formula
The
came from.
correct diameter.
Right, no, where this formula came from, and you're saying that it's based on the curvature of the Earth. So they're assuming that it's a sphere, but with what diameter? Do you know?
I don't know the actual. I
Okay,
can't remember the actual.
alright.
radius
What
of
is
the
it,
Earth.
24,000 nautical miles?
I don't know, I'm trying to
The
figure out where
diameter
they
of the
came
Earth
up
is
with this.
24,000 nautical miles.
24,000 nautical miles? Okay.
Okay.
All right, thank you, David. Appreciate that. Appreciate you handling that. That was great. All right, we got one more quick little presentation we want to do. This won't take long. It's pretty quick. We'll get through it and still get you out of here pretty close to on time. All right. Can I have your attention, please? Thank you. All right. So one last area, and this, we needed someplace to fit this in, and tonight we fit it in. It may not make sense logically and where we are in the class, but it's just a quick one on sailing gear. Okay, some of the things you should think about having for sailing gear when we go out on our level 2 class, water class. Okay, grab this too.
Oh yeah, thanks.
Uh-huh. All right. All right, so preparing, dressing for the inner lakes, you have to dress sensibly for the kind of weather you have. But sometimes on kill boats, you can be out for a lot longer periods of time. And in fact, if you go up to the North Channel, you're out there for a week, right? So depending on how long you're out, you need to make sure you have at least the right kind of gear. One of the things that we use on Lake St. Clair and in the North Channel are the type 5 PFDs. This one here has, and a lot of them have a water sensor, and will, if you hit the water, they blow up, right? They have a gas canister in them, and when you hit the water, they'll expand, and they, this 33 pounds of flotation is actually a lot, okay? And a lot of them you can have these D-rings on them, on the belt, and that's great, so you can attach a harness for when you're out in rough weather, okay? And I'll talk a little bit about that, but we occasionally will want to be able to go up into the bow, okay, if something's wrong on the bow, and if the water's very rough, you might want to be tethered so you don't go overboard, okay? And so you can clip your tether to these D-rings, and it'll keep you from falling off the boat, okay? These are pretty expensive though. This cost is probably a few years old. I don't know with inflation what they would be today, probably even more. Do any of you have these already?
Yes.
Yeah, okay. All right. One thing about these, you should have them checked. All right, every year, at the beginning of the year, I blow mine up by hand. I don't use the canister. I blow it up, and I'll leave it overnight. I'll put some books on it or something to weight, and I'll leave it overnight and make sure it doesn't deflate. Okay, make sure it holds air. Also, on this type, there's a little pill in the sensor that melts when it hits water, and that pill needs to be replaced every couple of years. And not everybody does that, but you should replace the pill every couple of years. And the Coast Guard, or not the Coast Guard, the Coast Guard Auxiliary will check your PFD, no charge. They usually come around sometime in the spring. You'll see something announced probably down at JBM or somewhere, and it'll say, Coast Guard Auxiliary is checking PFDs, and they'll check it out, make sure it's in good shape for you. Right? There's another kind of PFD, the Type 3, and this is a lot less expensive and doesn't require any maintenance. You don't have to worry about replacing the pill or the canister or testing it, that kind of thing. But they won't turn an unconscious person over. Okay, so if you get knocked in the head and fall off the boat, hopefully you land face up if you're wearing one of these. Because if you land face down, it's not going to be much help.
The Type 5 does flip you over?
Yeah, Type 5 will flip you over. It has like a pad in the back of your head, and it'll swing you over. Okay. Other things you might want to have, a harness. Okay, if you're like that PFD I showed you, the first one, it had these D-rings. All right. If they don't, if you have the Type 3, you might want a harness. Now we keep on our keel boats, we keep a couple of harnesses. They're not great, but they would work in a pinch. So we keep a couple of harnesses on there so you can wear them. And then this is a tether. All right, this is a single clip tether. This is a double clip tether. I have. Well, I actually have both, because I bought one of these, and then a few years later, after I was going up on the bow a few times, I says, I think I want to get one of these. Because with this one, you can unclip one clip, keep the other one on, so that as you move up the boat, you're always tethered, right? So it's just a little safer, but it's also more expensive, right? These are not cheap. I think mine cost, many years ago, it probably cost about $150. Okay.
Sometimes they run lines up the.
Yeah, we'll do that too.
You guys do that at all, or do you
Yes.
just individually do it?
No, we'll run lines up both sides of the bow.
Okay.
Yeah, in bad weather. Yes. And we'll show you how to do that on water. Okay, and we'll actually show you. We also have tethers on the boat. They're single tethers, and they don't stretch, they're just a piece of rope basically, okay? But, you know, better than nothing. Okay, so, strobe light is also good. These strobe lights you put on your PFD, and if you fall into the water at night, okay, they flash. When they hit the water, they'll flash on and off, so that it makes it a little easier for you to be found. Right? I have one, you know, that I clipped onto my PFD, just in case I were to fall off. That's what they look like. There's all different kinds, okay, of those. And then a whistle. I have a whistle clipped to my PFD, okay, because it's a lot better than shouting. You can hear it a lot further. So those are things you might want to consider. I would say, you know, you don't need to grab all this stuff before we go out the first time. All right, you need a PFD, but you probably have a level 1 PFD, right? From your earlier sailing. So, you know, I wouldn't get all this stuff, rush out and buy all this stuff tomorrow or anything. But these are things you ought to think about getting and looking at. And at some point, if you're going to do a lot of sailing and kill boats, you probably should have them. Yeah, Mike.
The one type you didn't mention, there's one that kind of looks like a fanny pack.
Yeah. Yeah.
What are your thoughts on those?
I tell you what, when I'm spending a week up in the North Channel and we're floating around easy, I wear that, okay? But if it's at all sailing hard or in rough weather, I always have on my Type 5 PFD, okay? So, yeah, they're okay for very calm conditions.
Because you have to put it on in the water.
Yeah, you have to.
Yeah.
You know, I've often thought I need to try that. I've never done it, but I was thinking, I don't know if I could even get the darn thing on in the water, right? You know, I would hope so, but, you know, at least I could grab onto it if nothing else.
Certainly won't help if you're unconscious.
No. So, you know, yeah, well, that's what I use in Kensington and Kent Lake, right? I use one of those. That's all you need out there. But, yeah, if you're out in any kind of weather, you're going to want something more. Foul weather gear, really nice to have. We do go out in the rain, okay? We hold class if it's raining, all right? Sometimes, if it's a thunderstorm and lightning, we don't go out. Okay, if there's a chance of lightning, we won't go out. But if it's just rain, we'll be out there. And sometimes we'll get out there in a beautiful morning, but by, you know, on a Saturday or Sunday, and by the middle of the afternoon, it's raining. So it's nice to have some kind of foul weather gear. You know, you can get stuff that's really expensive and really nice. If you're going to spend a lot of time out on the water, it's good to have. If you're just an occasional day sailor, you know, you could get away with something a lot lighter. I have rain gear for hiking, okay, that's real light, and if I'm going out for a day sail on Lake St. Clair, I use that. Okay? But if I'm going up to the North Channel and I'm going to be out there a week and it could rain all day, you know, I have pretty heavy duty rain gear, right? And boots. Lake St. Clair, I don't wear boots, I just have wet feet. You know, you're out there for the day, so you know, you got to judge how you're going to use them and how much you're going to use them as to how much you're going to invest in that. Other things, I think you probably needed these for level 1, right? Sunglasses, hat, and yeah, sunscreen. I always use SPF 50. I never use anything less. And again, you probably use these for level 1, right? A clip for your glasses if you have them, and a hat clip. Okay. We've lost hats out on Lake St. Clair, and we've lost phones out on Lake St. Clair. several people have lost their cell phone out there. There's a lot of, we'll get into it later in our GPS when we talk about chart plotters, but a lot of people use chart apps on their phone, okay? And that's great, except you do run the risk of your phone going overboard. Yeah. So you might want to tether for your phone. All right, and when we go out on the weekends, we're definitely going to want to bring, for our classes, we're going to want to bring lunch, okay, and snacks and a good bit of non-alcoholic drinks. Okay. So to stay hydrated. So, and yeah, water is good. I mean, that's typically what I have. All right. Also, you probably already have sail gloves. For level 1, you probably got your sail gloves, right? But you definitely don't need them on the bigger boats because the lines are heavier. They pull a little harder, all right, and it's easier to get burns. So definitely, it's great to have gloves. And the shoes, deck shoes, are really very helpful. Our decks do get slippery. We climb all over them all the time. We're climbing all over them, so it's great to have a good pair of deck shoes. And this razor siping is supposedly the best. What it is in the bottom of the sole there'll be very thin, like razor cuts in just a line after line after line of razor cuts in the sole, and that's supposed to let the water squish away and keep you from slipping. So deck shoes with razor siping are the best. Okay, but you need some kind of a deck shoe because it will be slippery, and if it's raining, it'll be very slippery. Okay. If you're out a lot, you might want to get one of these. I don't have one. There have been times where I said, it's probably a good thing to buy. When we get up to the North Channel, where we're on our level 4 boat, we're out for a week, and you go out on a dinghy. Okay, you go to shore in a dinghy. It's nice to have a radio, okay, to call back. Because up in the North Channel, you don't have any cell service. Okay, your phones don't work up there. So it's nice to have one of these radios so you can call back to the boat if you need to. A hand radio. But for Lake St. Clair, for level 2 sailing, you don't need one of these. Binoculars, we have those on the boat. So you don't really need to get your own. What other gear they talk about? Okay, I had shown you what a hand-bearing compass is like. We also have those on the boat. Okay. The ones we have on the boat, I don't really like that. It's a different style, and I don't really like it, but it works. You might want to get a sailing knife. That's for basically to cut lines if you get tangled. Okay, it's rare that I don't know that I've ever used my knife. Okay, my sailing knife, but I've heard cases where boats have capsized and people have been caught underneath the boat, tangled in lines and couldn't get out. Okay, and having a knife would maybe save their life. So it's one of those none of our boats have ever capsized and turned over, so I don't know how important that is. Okay, like I say, I would not go out and buy a GPS anymore. I have one, a handheld GPS. There are phone apps now that work really well, and that you can get free charts for them. Whereas I know I have a Garmin. Okay, I can't even get charts for it anymore. They won't even sell them to me anymore. Right, so my charts are old, and the Garmin I bought, I'd say it's maybe 8 years old, right? And they quit making charts for it. so I've had enough of Garmin.
What phone apps do you recommend?
Oh, I don't know which are the best. I've got a couple folks coming in later, one of our later classes in April, and they're gonna talk a little bit about the different apps. Also, we've had some of these, our monthly meetings, you know, our Zoom meetings, monthly, what's it called?
Harness the Wind?
Harness the Wind. We've had a couple of those over time where a different member will come in and talk about their app and how to use it. And some people favor one, some people favor another. Navionics makes a pretty good one. So, but also, so if you're, again, if you're on Lake St. Clair, it's not all that big a deal. Okay, we've got chart plotters on our boats, and all you need to be able to find is the North Buoy, right? You know, I mean, there's not a lot that you need to find. If you go over to Canada, you know, and you're looking for the entrance to the Thames or the entrance to the Bell River, it might be handy, but there's not a lot of use for them. Do you have a comment on that, Paul?
If I could just make a plug for one of the apps that is free, and the charts are the exact same chart that you have on your table, that's iNavX. Some of the others have really nice charts, but I like it that they're actually the government charts. You can just zoom in and out, and pretty simple, it's iNavX.
It's free.
And the charts are free.
Really good. I tested comparing to avionics.
Yeah.
Only one point, you have to know chart number.
Oh, you have to know your chart number.
You cannot switch from one screen to another. You have
It's
to
helpful.
take your hand and see, well,
You can zoom in and
this
out with it too, but it's
is the only thing, everything else is.
Hey, Paul.
Especially as you're learning, it's just nice that it's the same chart that you have there, so that you can make those comparisons.
Hey, Paul, would you be interested in giving maybe a brief demo discussion of iNavX at one of our later meetings?
Sure. Yeah.
All right, all right. I like to sign people up. All right, all right, that's it.
Paul,
So
Yes.
what are the homework? The homework.
if you,
Oh, it's not handwritten.
until you decide you really love sailing and you're gonna stay with it, wait a while before you buy all the stuff. But when you do, I know West Marine on certain months, December especially, January, February, they offer sales on some of these things, you know, so you might keep that in mind if you wanna get something a little cheaper. The other thing is, don't buy, if you get boots, don't buy them with the tops open, really open. I mean, where one of our instructors in the North Channel fell in and the water filled the boots. That's not fun, trying to get your boots off. So if you decide you wanna buy boots, buy them that are tighter to your ankles.
That's a very good point. I've got the
Yeah.
open ones at the top, and I don't use them. Okay, for homework. What do we have for homework,
Oh, yay,
Trudy,
homework.
on
The next
navigation?
two. The next two, and, the hint is that on one of those examples, you're gonna have to figure the water level. The one that you got to learn on is for 2022, but it's not 2022 anymore. So you have to key in something and find out what it is, and I'll let you figure where you have to.
Okay, so what are the problems you have? What exercise?
Well, in the very next two, we've done the first three, in the front of your navigational, pages there, you've got what they are. All you gotta do is look at it.
So we're doing three and four.
Right, right, and there's a page in there that tells you your assignments for every single assignment. This page here has them all. You're
All
gonna
right.
get two each time.
All right, so then your reading assignments, all right, I gave you, in the primer, I had given you 1 to 16, but 17 to 23, we also covered last week, pages 17 to 23. And this week, we covered on to page 34, okay? Page 35 through 38 are navigation, advanced navigation, they're optional. If you're interested in, if you love navigation and want to do more, okay, you can do what's on page 35 to 38. That's optional. But you should read the primer up to page 34.
Is there anything in the textbook?
Nope, I'm wrong. I'm sorry. Up to page 34. You can skip 35 to 38, but then 39 to 44. So I guess everything up to page 44, except for the optional 35 to 38. Okay?
We finished the book.
Was that good? Was that clear as mud?
Yeah, we're just finishing the book.
All right, and then in the basic cruising, the only additional reading there is page 90 to 92.
90 to 92.
That's it.
Can we do the, in the morning?
And I won't have to brush it off.
All right, so unless there's anything else,